Today we are going to learn about some zeros and ones. First, we're going to start by converting decimal to binary. Because it's a binary number system, we're going to start dividing by 2 because of the prefix by means 2. We have our decimal number here, 117. We're going to take 117 and divide it by the 2, and we get 58 with a remainder of 1. We take the 58 and divide that by 2, and we get 29 with a remainder of 0. Then we get the 29, divide that by 2, we get 14 with a remainder of 1. 14 divided by 2 is 7 with a remainder of 0. 7 divided by 2 is 3 with a remainder of 1. 3 divided by 2 is 1 with a remainder of 1, and 1 divided by 2 is 0 with a remainder of 1. When writing our binary number, we have to read from right to left. So we're going to take this 1 and put it in our first position right there. Then we'll take 1 and put it there, 1, put it there. So our numbers are, you take the remainders, the 1, 1, 1, 0, 1, 0, 1. So we have 1, 1, 1, 0, 1, 0, 1 there. Binary number has 8 positions, so I have only 7 numbers here. So I'm going to add a 0 to the front of my number just as a placeholder. So the number reads 0, 1, 1, 1, 0, 1, 0, 1. Now we're going to learn binary to decimal. Oh, sorry. We have our number 1, 0, 1, 1, 0, 0, 1, 0. That's our binary number, and we have to make it a decimal, which is just like a normal number. So each of these ones and zeros has an exponent with it. We start from right to left. We have 2 to the 0 power, and then we go all the way up to 7. So we have 2 to the 0, to the first, to the second, and so on. Then you're going to take all these numbers with 1s in them, and you're going to take their exponents and add them. So we'll start with 2 to the 7th. 2 to the 7th has a 1 in the spot, so we'll take 2 to the 7th plus, then we're going to go to 2 to the 6th. It has a 0, so we're not going to use that. Now we skip to 2 to the 5th, and that has a 1 in it, so we're going to take 2 to the 7th plus 2 to the 5th. 2 to the 4th has a 1 in it, so we're going to take 2 to the 5th plus 2 to the 4th, and we skip to the 2 to the 3rd and 2 to the 2nd, and we just take 2 to the 1, and we add all those up. 2 to the 7th, that's 128, plus 2 to the 5th, 32, plus 24, 16, plus 2 to the 1st, which is 2, which equals 178, and that is our decimal number. Now for hexadecimal number system, we have letters included in these numbers. An A represents 10, B 11, C 12, D 13, E 14, and F 15. If you see those letters, then you just have to substitute those numbers. For a hexadecimal to decimal conversion, we have our number 8C. We do the same thing, except instead of a 2 with the exponents, we're going to have a 16. So it's going to be 16 to the 0 power, 16 to the first power for each number, reading from right to left. We take our value of our exponent, so we'll start with C. C is 16 to the 0 power, and we multiply it by the number, which is C, and C up here says C equals 12, so we're going to do 16 to the 0 power times 12, which is equal to 1 times 12, which is 12. Same thing for 8. 8 is 16 to the first power, and you multiply it by the number, which is 8, which equals 16 times 8, and that is 128. Then you're going to add the 2, 12 plus 128, which is 140, and that gives you your decimal number. If you want to go hexadecimal to binary, then you just take your decimal number and repeat the same pattern up here of converting a decimal number to binary system through long division.